In this video, we're going to do a stoichiometry problem. And stoichiometry rests on the idea of mole-to-mole conversions, because keep in mind that different atoms do not have the same mass. So when we're trying to compare them to each other, we need some way of consistently comparing them. This problem is asking us to calculate how many grams of barium sulfate will be formed when 53.2 grams of barium chloride is mixed with an excess of sodium sulfate. The first thing we need to do is write a balanced chemical equation, which means that we need to turn these names into chemical formulas. So it looks like we are reacting barium chloride with sodium sulfate, and barium is in group 2A on the periodic table, which means it's going to lose 2 electrons and it's going to have a charge of +2. Chloride is in group 7A, which means it has 7 valence electrons and it needs to gain 1 more to have an octet, so we'll have a charge of -1. When you are writing a chemical formula of a compound, we're going to cross the charges. So the 2 is going to go behind the chloride. You can bring the 1 down from chloride, but keep in mind that whenever the subscript is 1, you can basically just eliminate it. So we're just going to write this as BaCl2. And we'll do the same thing for sodium sulfate. Sodium is in group 1A, which means it loses 1 electron and has a charge of +1. Sulfate is a polyatomic ion, so that one you would need to know. That is SO4 2-. And we'll do the same type of thing. We're going to cross the charges. So the 2 from the sulfate will go behind sodium, and you could bring the 1 down from the sodium behind the sulfate, but it's a bit redundant, so we can just leave it the way that it is. Keep in mind that whenever you cross the charges, the plus and minus signs go away. You're just bringing down the number to indicate how much of this atom you're going to have in the formula. So now we have our reactants. Let's write the chemical equation. We are reacting barium chloride with sodium sulfate. And the first thing we need to think about is what type of chemical reaction is this going to be? Well, keep in mind that we have 2 cations and 2 anions, which means this is going to be a double replacement reaction. And what we're going to do is change the order of the cations. So it's actually helpful to have the ions that we started with here, because then we don't have to go backwards and uncross those charges to go back to where we came from. Okay. Barium was bonded to chloride, which means I need to give it a different anion, and the only other anion present here is sulfate. And I'll do the same thing for sodium and chloride. I will bind those to each other. Notice that when barium and sulfate come together, they have a charge of +2 and -2, which means that those charges are just going to cancel. So our product will be BaSO4. We don't need to cross charges here. Same type of thing on sodium and chloride. They have a charge of plus and minus, so those charges will cancel and we just get NaCl. Okay, now that we have that, we need to make sure that this equation is balanced, and it definitely isn't. We have 2 sodiums on the left and only 1 on the right. So what I'm going to do is multiply that by 2 to account for that. And then I'll check everything else. It looks like that also takes care of the other chloride on the left-hand side. Then we have 1 barium on the left, 1 on the right. That's good to go. 1 sulfate on the left and 1 sulfate on the right. And whenever you're dealing with a polyatomic ion, you can treat it as a whole unit. You don't have to separate all of the atoms and count them individually. So it looks like this equation is now balanced and good to go. Let's go back to what our problem is asking us to do. So it wants us to calculate the grams of barium sulfate that are being formed. And it's telling us that we have 53.2 grams of barium chloride. The excess of sodium sulfate is really just telling us that we have enough sodium sulfate for this reaction to go to completion, so we don't actually care about sodium sulfate. Okay, So we know the grams of barium chloride. That is what we're putting into the reaction. So I'm just going to start there. And then we need to figure out how we're going to get to grams of barium sulfate. Well, keep in mind that we don't have a gram to gram relationship between those two because the mass of barium chloride is going to be different than the mass of barium sulfate. And the only way to compare them to each other is to use a mole-to-mole ratio. Well, our mole-to-mole ratios are going to come from the balanced chemical equation. So they come from these coefficients in front of the chemical formula. Now notice that there are no coefficients listed before barium chloride or sodium sulfate. That really means that all of these coefficients are 1. So for every 1 mole of barium chloride, we're going to produce 1 mole of barium sulfate. Once we have that information, we can convert one to another. The problem is that we're given grams of barium chloride, and in order to use this conversion, we have to somehow get that into moles. Well, in order to be able to do that, we need the molar mass of barium chloride. So we're going to have to calculate that before we can proceed. So we'll get the molar mass of barium chloride and the molar mass of barium sulfate. Okay, so for every 1 mole of barium, I'm going to write that down. That's going to come directly from the periodic table. And I'm going to look that up here. It looks like 1 mole of barium has a mass of 137.327. So if I were to weigh a mole of barium, that's what its mass would be. And 1 mole of chloride has a mass of 35.453. And note that I'm keeping a lot of sig figs here just so that I don't get any errors from rounding. So I'm going to round at the very end. Now keep in mind that in the formula we actually have 2 chlorides, so we need to multiply that by 2 to account for that. And that's getting me a mass of 70.906 for the chloride. The barium I can just copy because we only have 1 of them in the formula. And then I'm going to add all of that together. And that's saying that if we were to weigh 1 mole of barium chloride, the compound, it would have a mass of 208.233 grams. Another way you could express that is by saying that the molar mass of barium chloride is 208.233 grams per mole. And now we'll do the same thing for barium sulfate. We already have the mass of barium. Sulfur I will look up. And it looks like the mass of sulfur is 32.065. Okay. Notice that we have 4 oxygens in the formula, so we need to multiply that by 4. Okay, that's giving us a mass of 63.996 grams just from the oxygen. And then we have to add all of these up to get the molar mass for the entire compound. Okay. And if we add all of that together, one mole of barium sulfate will have a mass of 233.388 grams. Okay, now we can use that information in our stoichiometry problem. So we are given that we're putting 53.2 grams of barium chloride into the flask, and I want to convert that into moles of barium chloride. Well, keep in mind that whatever unit is up top, we need to put the same unit on the bottom in order to be able to cancel it. So in the denominator, I'm going to use the molar mass because I know that for every 1 mole of barium chloride, we said that had a mass of 208.233 grams. Okay, well, if I want to cancel grams over here, then I'm going to put the grams on the bottom and 1 mole of barium chloride in the numerator. Okay, this now cancels the grams of barium chloride, and we're working with moles of barium chloride right now. But we're interested in grams of barium sulfate. So I can use the conversion that came from the balanced chemical equation that is telling us that for every 1 mole of barium chloride, we have 1 mole of barium sulfate. Well, I want to get rid of barium chloride because I'm not really interested in that. And since barium chloride is up top here, I'm going to put 1 mole of barium chloride in the denominator. And 1 mole of barium chloride will give us 1 mole of barium sulfate. Now we can cancel the moles of barium chloride, and I can finally convert the moles of barium sulfate to grams of barium sulfate. And that we can get from the molar mass that we just calculated. So we said that in 1 mole of barium sulfate, it will weigh 233.388 grams. I ran out of space here. But I'm putting moles of barium sulfate on the bottom so that I can cancel it up top here. And now our answer is left in grams of barium sulfate. So in order to get that number, we're going to multiply everything up top and divide by everything on the bottom. And if I plug that in, I'm multiplying 53.2 by 233.388. And then I'm dividing by 208.233. And that's getting me 59.6 grams of barium sulfate. I'm keeping 3 significant figures here because the problem started with 3 sig figs, so that should be good too.